Welcome to the introduction of Python variables. In this lesson, we will be covering the foundation of Python programming. Variables are containers for storing data values. In Python, variables are created the moment you first assign a value to them. Unlike many other programming languages, you do not need to declare variables before using them in Python. There is no need to specify a data type either. For example, as shown in the code, to create a variable called name and assign it the value John, simply write name equals John. Similarly, age equals 25 and is student equals true are also valid variable assignments. To use these variables, you can simply call them in functions like print. As shown, when you print name, the output will be John. Here's an explanation of the syntax used to declare variables in Python. When assigning variables, use the equals sign. The variable name should be on the left side of the equals sign, and the value or expression that you want to assign to the variable should be on the right side. In Python, you do not need to use keywords like var, let, or const, which are used in some other programming languages. Let us look at some examples. To assign the value of 10 to a variable x, you simply write x equals 10. To assign the text hello to a variable message, you can write message equals hello. You can also assign the result of an expression to a variable. For instance, to assign the sum of 5 plus 3 to a variable called SumResult, write SumResult equals 5 plus 3. If you want to reassign a variable to a new value, you can simply write the variable name followed by the equals sign and the new value. For instance, if you want to increment the value of x by 1, you can write x equals x plus 1. Here are the rules and guidelines you should follow when naming variables in Python. Variable names must start with a letter or an underscore. They can contain letters, numbers, and underscores. They cannot start with a number. You also cannot use reserved keywords as variable names such as if, else, for, while, and so on. Keep in mind that variable names are case-sensitive, so age is different from age. Let's look at some examples of valid variable names. User underscore name equals Alice. Underscore hidden equals 42. Camel case equals value. Age 1 equals 25. Now let us examine some invalid variable names. One user equals Bob is invalid because it starts with a number. User dash name equals Carol is invalid because it contains a dash. Class equals Python is invalid because class is a reserved keyword in Python. Python has several built-in data types that you can assign to variables. Here is a list of some of the most common ones. str, which represents text data or strings. Int, which represents integer numbers. Float, which represents decimal numbers. Bool, which represents true or false values. List, which represents ordered collections of items. None, which represents the absence of a value. Here are some examples of different data types being assigned to variables. The variable name is assigned the string value Alice. The variable age is assigned the integer value 30. The variable height is assigned the floating point value 5.9. The variable as student is assigned the Boolean value true. The variable hobbies is assigned a list of strings, reading and coding. The variable address is assigned the value none, which indicates that it has no value. You can check the type of a variable using the type function as shown here. The type of age is int, which stands for integer. Python provides a way to assign values to multiple variables in a single line of code, which can be quite convenient. There are several techniques to do this. You can assign the same value to multiple variables. You can assign different values to different variables. You can also unpack values from a collection, like a list or a tuple, into multiple variables. For example, you can assign the same value to multiple variables by chaining the assignment operator. In this case, x, y, and z are all assigned the value 10. To assign different values to different variables, you can use commas to separate the variables and their corresponding values. In this case, A is assigned 5, B is assigned the string hello, and C is assigned the floating point number 3.14. You can also unpack a list or tuple into multiple variables, as long as the number of variables matches the number of elements in the collection. In this case, the colors list is unpacked into the R, G, and B variables. Finally, you can also swap the values of two variables in a single line using multiple assignment. In this example, M and N are initially assigned the values 1 and 2 respectively. Then their values are swapped using multiple assignment, so M becomes 2 and N becomes 1. Python provides built-in functions that allow you to convert between different data types. str converts a value to a string. Int converts a value to an integer. Float converts a value to a floating point number. Bool converts a value to a boolean. List converts a value to a list. For example, if you have a string that represents a number, you can convert it to an integer or a float using the int or float functions. You can also convert a number to a string using the str function. Converting to boolean is a different ball game. An empty string will return false, whereas a non-empty string will return true. In Python, variable scope determines the region where a variable is accessible. There are two main types of scope. Local scope refers to variables defined inside a function. These variables are only accessible within that function. Global scope refers to variables defined outside of any function. These variables are accessible from anywhere in the code, including inside functions. Enclosing scope refers to variables in outer functions. Python follows what is known as the LEGB rule, which determines the order in which Python searches for a variable. It starts with the local scope, then the enclosing scope, then the global scope, and finally the built-in scope. Here is an example. The variable message is defined outside of any function, so it has global scope. Inside the function myFunction, a variable name is defined which has local scope. When we print name inside the function, it outputs Alice because name is defined locally within the function. When we print message inside the function, it outputs hello world because message is a global variable that is accessible from within the function. When we print message outside the function, it also outputs hello world because message is a global variable that is accessible from anywhere in the code. However, if we try to print name outside the function, it will raise a name error because name is a local variable that is only accessible within the function. Constants are variables whose values should not be changed after they are assigned. However, Python does not have built-in constant types, so constants are typically defined by convention. By convention, constants are written in all uppercase letters, and they are typically defined at the module level. However, it is important to note that this is just a convention, and Python does not enforce it. This means that constants can still be changed after they are assigned. Here are some examples of constants defined by convention. PI equals 3.14159. Max connections equals 100. Database URL equals mongab://localhost. Here is how you can use them. To calculate the area, you can define a function calculate area that takes a radius as input and returns pi times radius squared. To use a constant in separate modules, you can define it in a separate file such as config.py, and then import it into your main program. Following these best practices can improve the readability, maintainability, and reliability of your Python code. Use descriptive and meaningful names for variables. This makes it easier to understand what the variable represents. Follow a consistent naming style, such as using snake case for variable names. Avoid using global variables when possible, as they can make it harder to reason about the code. Initialize variables before using them to prevent errors. Keep variable scope as small as possible to reduce the risk of unintended side effects. Here are some examples. Instead of using poor variable names like a equals 10 and x equals John, use descriptive names like age equals 10 and username equals John. Instead of using inconsistent naming styles, follow a consistent naming style such as first name equals Alice, last name equals Smith, and email address equals alice@example.com. Here are some common mistakes to avoid when working with variables in Python, along with tips for troubleshooting them. One common mistake is using variables before they have been assigned a value. which will result in a name error. Another common mistake is making typos in variable names, which will also result in a name error. It is also important to be aware of variable scope and avoid confusion between global and local variables. Type errors can also occur when performing operations on variables of incompatible types. Finally, avoid reassigning built-in functions, as this can lead to unexpected behavior. If you encounter a name error, make sure that the variable has been assigned a value before it is used, and that there are no typos in the variable name. If you encounter a type error, make sure that the variables you are operating on are of compatible types. For example, here are some errors in code. First is the name error where you try to print the count without declaring. Second is a typo in the variable name. Third is overriding built-in functions, and fourth is a type error. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.